Welcome to another Intermediate Algebra video. In this video, we'll look at the quote-unquote division of radicals, or ultimately rationalizing radicals. So our one and only objective, which has two parts to it, is to rationalize denominators. And we'll do this with one-term denominators and with two-term denominators. We won't see anything more than that. So here are the notes. For this section, rationalizing, and this is kind of the important piece, just to understand what it is we're doing. Rationalizing is using algebra to clear a radical out of the denominator. It's possible to see problems where you're asked to rationalize the numerator. I would not expect to see that in this course. Typically, in actuality of math, we really only do it to the denominator. So when something says to rationalize, it means find a way to use some algebra to clear the radical out of the denominator. If we have one term, it's a pretty simple decision to make. In fact, I don't even have notes for it. It's such a simple decision. But if we have two terms, the method we're going to use is multiplying the top and bottom by the conjugate of the denominator. And so here's what a conjugate is. As we kind of mentioned in a previous video, conjugates are the same binomial with an add and subtract in the middle. So this is an example of conjugates. So if this was the given denominator and we were looking to rationalize it, we would multiply the top and bottom by the conjugate, the plus version of that denominator. The reason that this works out so nicely is that if we were to FOIL this out, which is exactly what we'll do when we multiply with the two terms, the a would get distributed to each piece. We'd have a squared plus ab. Then the b would get distributed. We'd have minus ab minus b squared. Now imagine there's going to be radicals involved somewhere in a and or b. If we have it in a, well, now a is something that's squared. And a square on a square root cancels out. So that's good. The middle terms are a plus ab and a minus ab, which cancel out, which means the radical would not be there. And the only place that's left is b, but again, if b has the radical, b is being squared, so the squared would undo the square root. So you would be left with, now you will actually carry out that computation, but it'll undo the square root, the radical in every case. And you'll get a denominator that no longer has the radical, which is the ultimate goal of rationalizing, using algebra to clear a radical out of the denominator. This conjugate is just a specific way to do that. So let's look at the one-term pieces first. Okay, the directions say rationalize, and all variables are non-negative. So here's what we currently have as a fraction, 2 over the square root of 5. And we no longer want the radical to sit in the denominator. So we're going to choose to multiply the top and bottom by something. This is what we choose, so that the radical will no longer be in the denominator. Currently we have square root of 5, so what would we need to multiply in for that denominator to be something that is quantity squared, so we can undo it? Well, if we chose to multiply in the square root of 5, our denominator would be the square root of 25, which is 5. And then we no longer have that radical in the denominator. So we choose square root of 5, and then with any fraction multiplication, it has to be done to the top and bottom. And the reason is that if we're multiplying by anything that's the same top and bottom, it means we're multiplying by form of 1. So we're not changing anything. We're just kind of chopping up all the information we have or dressing it up a different way. We're just looking at it another way. So we choose square root of 5 over square root of 5 to multiply by, and then actually carry out the multiplication. So straight across, 2 times square root of 5 is 2 square root of 5. The denominator, as we already saw, square root of 5 times square root of 5 is square root of 25, which is 5. And then the numerator, in this case, doesn't simplify anymore. So we get 2 square root of 5 over 5. It might seem silly, But the best reason I can give you on why the radical should not be in the denominator is that we first started computations when mathematicians first started doing this years ago. They would have to do everything by hand. And so if the radical was in the denominator, it meant they were doing long division with a decimal that went on forever on the outside. So it made it a very complicated computation. So as a standard practice, we get rid of the radical in the denominator. A radical in the numerator is okay, because we can have a crazy number in the inside. It's on the outside. You don't want to be dividing by a number decimal that goes on forever. A decimal number that goes on forever. Okay, so for the second one, we have 2 square root of 16 over square root of 9x. Again, the ultimate goal is to not have a radical in the denominator. Numerator is fine. So we make the decision to multiply by something the same, top and bottom, to get rid of that radical. So one way, and we'll go through this one a couple different ways, would be to multiply the top and bottom by that exact radical, the square root of 9x. Okay, so if we choose that, in the bottom we have the square root of 81x squared, which simplifies to 9x. And in the numerator, we have 2 square root of, now I'm not even going to carry out this multiplication because I know what's going to happen next is simplifying. I would ultimately take that number and break it back down. So without even multiplying, I can see there's a 2 already on the outside. This square root of 16 is a 4. This square root of 9 is a 3. And then what's left inside is the x. Clean this up a little. 2 times 4 times 3 is 24. Square root of x all over 9x. And then we can actually simplify this one a little bit further. The 24 on top and the 9 on the bottom both have a 3 in common. So we can divide out a 3 from top and bottom, which gives us 8 square root of x over 3x. And you might be wondering, well, what about the x's? I see an x on top and an x on the bottom. But the one on top is underneath the square root. It can only interact with things that are also in the square root. So this is one way to simplify this problem. Another way would be to start out by doing some simplifying. So you might recognize in the numerator, hey, that square root of 16 is a perfect square. It can come out as a 4. And in the denominator, there's a perfect square of 9 in there, so that can come out as a 3, leaving me with square root of x, which simplifies to 8 over 3 square root of x. And then, still, the ultimate goal of rationalizing is to get rid of the radical in the denominator. So, again, we choose to multiply by something, top and bottom. And because our radical only has the square root of x now, we could choose just to multiply top and bottom by square root of x. So, multiplying straight across would give us 8 square root of x over radical multiplication is outside by outside, inside by inside. So 3 times 1, 3. Square root of x times square root of x is square root of x squared. And then that x squared comes out as a single x. So we get the same answer either way. Another common question is, at this stage, let's say I started out by simplifying, and I got here to this 8 over 3 square root of x, but then I chose something different. What if I chose instead to multiply by 3 square root of x? What if I chose the exact denominator? What would happen? Well, if you chose that exact denominator, you would end up with this line, 24 square root of x over 9x, which would ultimately still simplify to the same thing. So the good news with rationalizing with one term in the denominator is that you have options. So if you pick something that's too big, it's fine. It'll all simplify out in the end. But remember that the ultimate goal is just to not have a radical in the denominator. which we have accomplished. All right, a couple more. All right, so another one-term piece. We have a cube root of 1/2. The goal is to rationalize, to get rid of the radical in the denominator. But before we can do that, we really need to see this problem as a radical on top and or bottom. So we can separate this using the product rule to be a cube root of 1 over a cube root of 2. Now, on top, it's a cube root of 1, so we're looking for something that multiplies by itself 3 times to give us 1. And in this case, it simplifies, to just 1. Whether you do that now or later, it doesn't matter. The denominator still is the cube root of 2. Okay, so the goal is to get rid of the radical in the denominator. So again, we're going to choose to multiply by something. And in the previous problems, we've chosen the exact denominator or the exact radical in the denominator. But now we have a cube root, which means we're looking for a group of 3. So underneath that radical currently, that cube root, I have a single 2. In order for that 2 to come out, I need 3 of them, right? You have to have 3 of them for a cube root. So how many are we missing? Well, we have this one. We need 2 more. So what should we choose to multiply in? It has to be a cube root. That's easy, top and bottom. But we're missing a 2 times 2. Ultimately, we're missing a 4. You could write that 4 as 2 times 2. You could write it as 4. Doesn't matter. So if we choose the cube root of 4, in the denominator, those 2 multiply and we get the cube root of 8. And remember, 8 breaks down to 2 times 2 times 2, which is a group of 3 2's, exactly what we're looking for. So a 2 comes out. And in the numerator, we have 1 times cube root of 4, so we get cube root of 4. And that's fine. There can be a cube, square root, whatever kind of radical in the numerator, but the denominator is where we want to get rid of it. So for most problems, it will be a square root, and in that case, you will choose the exact radical from the denominator. But just know that your rationalizing may not have the index of 2. If it has a different index, you make your decision based on what you have. So this was a cube root. We needed groups of 3, so we multiplied in 2 more pieces, the 2 and the 2, so we'd have our group of 3 to be able to take one out. All right, so here's this one. Okay, now let's look at a problem where we rationalize with our denominator having 2 terms. Remember that this is going to involve us using the conjugate. So let's first identify the conjugate here. Our denominator is square root of 3 minus 2. And conjugate is that exact thing with the opposite sign in the middle. So the conjugate would be root 3 plus 2. So this is the thing that we choose to multiply in top and bottom. And you'll see why. It's the same reason that a squared minus a minus b times a plus b simplified down to something nice. All right, so now we have to carry out each of these multiplications. So the numerator, let's do it here. The numerator has 5 times the quantity, square root of 3 plus 2. So distribute. 5 times square root of 3 is 5 root 3. 5 times 2 is 10. Nothing else you can do with that numerator. Then the denominator has root 3 minus 2 times the quantity root 3 plus 2. This will involve FOIL. Just like we did in the multiplication section, root 3 times root 3, root 3 times 2. So we have the square root of 9 plus 2 root 3. Then the negative 2 times each term, minus 2 root 3 minus 4. Okay, clean this up. The plus 2 root 3 minus 2 root 3 cancel each other out. The square root of 9 is a perfect square, giving us a 3. And in this case, they're both numbers, so 3 minus 4 is negative 1. So our denominator crunches all the way down once we rationalize to negative 1. So our numerator can't be simplified in any way. Denominator, we got negative 1. So ultimately this solution, because it's a 1, you can give it as a denominator to each piece and simplify. So we get negative 5 root 3 minus 10. It's possible, very possible, that your denominator will have a variable on one piece and not on the other. So when you carry out this multiplication, you'll get down to a place like this, the 3 minus 4, where it doesn't combine, and then that would just be your denominator. You also might get to a place where the numbers do combine, but it's a 25. And if it's a 25, well, I guess 25 is a bad example because it could simplify. Maybe it's a 27. There's nothing you can do with any of those numerators if it's a 27. But a 1, we don't like to see a denominator of 1. You just clean it up a little bit more. So big picture, back to the beginning, is that first the goal is to get rid of the radical in the denominator. So we choose to multiply by the conjugate because we know that this specific thing will happen. These middle terms will cancel out, and the first and last term will be something that was squared. So if there was a square root, they can be undone. And then we won't have the radical anymore, which is the ultimate goal. Okay, let's do one more together and then some practice problems. Okay, so again, the directions are to rationalize. We have 2 terms in the denominator, so we'll need to use the conjugate. So what would the conjugate of this denominator be? It's presented with a plus in the middle, so the conjugate would be that exact thing with minus. So this is the thing that we choose to multiply top and bottom. I'm writing this choose every time so that you know this was a decision that you made, and then you go forward from there. Okay, so we have multiplication on top and multiplication on the bottom that we have to carry out. Let's do them here. So let's say here's our numerator. 3 square root of x times 2 square root of x minus square root of y. Distribute. We get 6 square root of x squared minus 3 square root of xy. Outside by outside, inside by inside. The first piece of the numerator can clean up a little bit. 6 square root of x, that square root of x squared comes out as an x, so 6x minus 3 square root of xy. So here's our numerator. Then the denominator, 2 square root of x plus square root of y, 2 square root of x minus square root of y. This involves FOIL. Use color. So the 2 root x times 2 root x, 4 square root of x squared, 2 root x times negative y is minus 2 square root of xy. Then the radical y gets distributed, becomes plus 2 square root of xy minus square root of y squared. I know at this stage it looks like, well, there's still 4 radicals, so nothing is working. But start to simplify. These middle two terms are the same, so they'll cancel out. The first term has a square root of x squared, so an x comes out. Don't be fooled, that 4 is on the outside. It doesn't become a 2. Only if it was inside would the 4 become a 2. And then the last piece is being subtracted, and a y comes out. So our denominator crunches down to 4x minus y. And the goal has been accomplished. No radical is in the denominator anymore. This one can't simplify any further because there's addition subtraction. You might be wondering if this x and this x could divide out only if those were the only two pieces sitting there. Because there's a plus minus or a subtraction after each of them, the only way you can simplify is to factor. And I wouldn't expect that on any of these problems. So here is our solution. So again, we chose the conjugate as the thing to multiply top and bottom by, so that in the denominator, all the radicals would cancel out. It's just a matter of carrying out each of those multiplications. All right, so 2 practice problems. Go ahead and go through these on your own, and we'll go through them together in a moment. Okay, so the first problem, rationalize, ultimate goal, to not have the radical in the denominator. So we choose to multiply top and bottom by something specific. We are going to choose the square root of 3, so that when we carry out this multiplication, we get 5 square root of 3 over square root of 9, and that square root of 9 simplifies to 3. So we get a denominator with no radical. Okay, the second one, we need the conjugate because we have 2 terms. This one has subtraction in the middle, so the conjugate will have addition in the middle. So this is what we choose to multiply the top and bottom by. Then carry out each multiplication. So let's do the numerator over here. This is a square root of 2 plus 5 times square root of 3 plus square root of 5. FOIL. Root 2 times root 3, square root of 6. Root 2 times root 5, square root of 10. Then 5 times everything, plus 5 times root 3 plus 5 root 5. And these are all different, and they all don't simplify. 6 is 2 and 3, no pairs. 10 is 2 times 5, no pairs. So that's as good as the numerator gets. Then the denominator, we have root 3 minus root 5 times root 3 plus root 5, FOIL, root 9 plus root 15, minus root 15 minus root 25. Middle 2 cancel, we get 3 minus 5, which gives us negative 2. And they don't all have a common negative 2, and you could separate them, but it's not necessary. Only when it's a 1 is it really expected that you give it to each denominator. So this is a rationalized 2-term in the denominator radical expression. All right, so in this video, we looked at rationalizing when the denominator had 1 term and when the denominator had 2 terms. The ultimate goal in both cases being to get rid of the radical in the denominator. All right, I will see you soon for another video.